Hey guys, this is Arvind, and this video is going to be about introduction to Solidity. So we are back on my favorite resource, which is Ethereum.org. So let's get started. Before going into the detail of Solidity, let us try to understand why do we need Solidity. So Solidity is a language used to write smart contracts on Ethereum blockchain. Now a new term which is smart contracts. We need to understand what are smart contracts. So smart contracts are essentially the fundamental building blocks of Ethereum blockchain. I know this was a confusing definition, so let me put it in front of you in an easier way. To understand smart contracts, let us try to understand the term contract, the traditional term contract that we hear so many times in our life. So, what is a contract? It is just an agreement that happens amongst multiple parties, which defines some set of rules and conditions, and what would happen if those rules and conditions are met. Let me give you an example to explain it better. So, let us say I am planning to buy a house from a guy called Bob. We discuss the formalities and then we create an agreement. This agreement can be either verbal or written. And the agreement states that whenever I transfer the money to Bob's bank account, the ownership of the house should get transferred to me. This is a typical example of a contract. So, if the contracts existed, why did we got the need of creating smart contracts? To explain the problems with the traditional contract, let me give you another example. Consider the same scenario where I created an agreement with Bob related to purchasing a house, and I go in and transfer the money to Bob's bank account. Then Bob comes back to me and refuses to transfer the ownership of the house to me even though he wrote the contract with me and he received the money. So basically, he decides not to respect what was written on the contract. What would I do? So, in the normal circumstances, the only option that I have is to go to a judicial organization or a court with the contract that we guys wrote and signed to ask for help, which means the contract is valid only if a trusted third party approves it or respects it. In this case, this is a judicial organization or a court. This is a limitation of the traditional contract that a trusted third party needs to be present whenever a contract is being created amongst the stakeholders, and they should approve this contract. Only then this contract is valid. So now the question arises that if I am the one who is making the payment and Bob is the one who owns the house and will eventually transfer the ownership of the house, why do we need this third party? The only reason we had to bring in this third party was to create trust between us and obviously resolve disputes if they arise. This is when the smart contracts come to help. So, smart contracts are just like the traditional contracts that we discuss, the only difference being they are smart in nature. Smart contracts work exactly like the traditional contracts with all the characteristics of a traditional contract. It just removes the need of that third party that we discussed. Here, the trust is created by a code which is deployed on the decentralized network of Ethereum. Smart contract 2, just like the traditional contract, cannot be modified once written and deployed on the Ethereum blockchain. And this is the main characteristic of a contract. This is the main reason why we write smart contracts. You can obviously write new contracts and replace the old ones, but you cannot modify once it is deployed. So that is all about the smart contracts. We can discuss more about it when we start writing the smart contract. Let us come back to the original topic of this video, which is solidity. What actually is solidity? We discussed that smart contracts use a piece of code to create trust. Solidity is the programming language which is used to write these smart contract codes. It is a Turing-complete object-oriented programming language. The syntax of Solidity is quite similar to JavaScript. So if you are a JS developer, trust me, it will be quite easy for you to learn. to write Solidity, we use this ID called Remix. This is an ID provided to us by Ethereum. The best benefit of using Remix is that it removes the need of installing anything on our machine. So you can just get started. All you need a browser. You can choose any of your browser, open a tab, and write remix.ethereum.org. The remix is ready for you to use and write Solidity code. Before going into writing code on remix, let me introduce you with the remix ID and make it easier for you to use. So the remix has majorly these three tabs that we will use in this course. First one is the file explorer, and over here you can create new files and create a folder structure and everything. And over here you will write the code. When you open a file, it will show up in this region, and here you can write the code. The second tab over here is the Solidity compiler, and just like all other programming languages, Solidity also has a compiler, and then there are so many different versions of a compiler. So over here you can see all the different versions of the Solidity compiler, and then you can choose your favorite version. We are going with 0.8.7 because that is the default version that Remix asked us to use. Then there are so many other options. You can explore them when you use Solidity. These options are majorly related to the Solidity compiler. In the next section, this is the deploy and run transaction section. This is the main section where we'll be interacting with the contracts. Before interacting with the contracts, we'll be deploying the contract on the blockchain and then interacting with the contract by calling different functions from here. So this is the third section. These are the mainly three sections of the Remix IDE. Coming back to the first section of Remix, which is the file explorer, and let's get started and write some real code, the real Solidity code. So over here you can click to create new files, and then we name this file hello world. That is what we write whenever we start using a language. So click open. So you can see I created hello world.sol. So .sol is the extension that we use for all the Solidity files. In the code, let me tell you what I'm going to write in this lecture. So we're going to create a hello world contract which has just one function which says get me a string, and when we call that function it should return a message hello world. That is the contract that we are going to write. So whenever we start writing the contract, the first line that we write, it's this thing, pragma solidity, and then we write 0.8.7. So pragma solidity basically informs the blockchain or the compiler that this file, this SOL file supports this specific compiler version. We can add this caret to say that all the versions above 0.8.7 are supported by this file. So if a compiler which is on version 0.3 or 0.4 tries to compile this file, it will throw an error because this file is only supported for 0.8.7 or greater compiler versions. Next thing that we write is contract. So as I told you previously that Solidity is an object-oriented programming language, and whenever we have an object-oriented programming language, we have something like a class. So in Solidity, we don't have classes, we call them contracts. So it is similar syntax, just like we create classes. So now we are creating a contract and we are naming it hello world, and then these curly braces. So whatever we write between these curly braces will be inside the contract. Cool. So as we discussed, we will be writing a function. So let me start writing a function. So function, always start with this function keyword. Then we write the name of the function, which is getString. Then we give round brackets. Within round brackets, we can add different arguments that we need to pass to this function. We don't need any arguments here, and we will discuss about arguments when we write complex contracts in future. The next keyword that we write is public. So public is an access modifier, which tells that this function can be called by anybody from outside the contract. So here we write public. There are other access modifiers, but we'll talk about them when we use them in future contracts. Then we write view. View basically tells that this function, so basically this function won't do anything with the contract or update any state. It is just going to view something which is already present in the contract code. So it is not going to update any variable. That's why we write view. And then we create these curly braces, and everything that we write in these curly braces is the is written inside the function. Next thing what we are going to do is write return and write hello world. So we are going to return this string, and at the end of this line we add a semicolon. So it's already just like all other programming languages, we need to add a semicolon at the end of each line. That's all that we need to write in this easy, simple contract. Let's go and try to compile it. I'm sure we'll see some errors. Let's see. Yeah, we saw this error. It says different number of arguments in return statements than in returns declaration. True. So in while writing Solidity, we need to define in the function definition itself. So this part which I have highlighted is the function definition, which tells the compiler about the function. So over here, after writing view, we also need to add a line which says returns, which basically tells the compiler what this function will return. So basically what this function will give out as an output. So in this case, it is going to be a string. So if we write any characters or a message, then it is a string data type in Solidity. Let's write string. And then we also need to write memory. Memory is also a keyword. It is something that we'll understand more about in future. But for now, just assume that whenever you write string, we need to write memory along with it. Cool. So let me save it, click compile again, and done. It has given me this warning which says function mutability can be restricted to pure. So we can choose to change the code accordingly or just ignore it, because if the compile is done, we can go ahead and deploy. Let's change the code because I personally don't like warnings. It looks to me just like errors. So like we wrote view. As I told you, view basically tells the compiler that this function is not going to update anything in the contract, not going to update any variable in the contract. Instead, it's just going to view something in the contract. But this function is not even viewing something which is written inside the contract. It is a pure function that it is not even accessing any variable that is written in the contract. So we can call it pure as well. So we write pure and then compile again, and yeah, it worked. It is asking me to add a license comment on the top. Let me add that as well, but that is not necessary. We can just ignore it. But let me add it because I told you I don't like warning messages as well. So yeah, it compiled well. We got mistake. Let's go to the third section of Remix, which is deploy and run transactions. So here we are going to deploy this contract. So for deploying contract, we obviously are not going to use the Ethereum mainnet, because for deploying contract, we need to pay some gas fees. So gas fees is basically something that goes to the different nodes of the Ethereum blockchain, which actually store data for Ethereum, the decentralized nodes. So I don't want to pay actual ETH just for this course, so I'm not going to use the Ethereum mainnet. Then we have options to use different test nets, but for now, for the ease, I'm going to use JavaScript VM. So JavaScript VM is basically a virtual blockchain that Remix sets up for us inside the Remix itself. So we don't need anything from outside. This is just a virtual machine or a virtual blockchain that Remix has set up for us to test things inside itself. So we have selected the environment. Also, when it set up the VM, it provided us with a couple of accounts. I think these are 10 accounts. We can choose any of them. I'm selecting the first one. Then we can set value and gas. We can skip it for now. then we need to select contract. Right now we just have one sol file, that's why it's just showing one. But when we create complex contracts, it will have multiple sol files, then it will show multiple contracts. We need to select our contract app correctly. So we select hello world, and then all we need to do is hit deploy. So when hit deploy, as you see, this is the console where everything you can see in Remix. It says that the transaction was mined and execution succeeded. So it basically deployed the contract, and we can also see the from address from which the transaction was fired, and also the transaction hash. So over here you can see this deployed contract section. It basically lists all the contracts which are deployed using this deploy button. And when you expand this part, you can see the function that we wrote, which is get me a string. And if we click this button, we'll get the output of this function, which is this return hello world. So let's just see, fingers crossed. I guess it worked with the first part. Yeah, it worked. And it returned hello world as we expected. So this is how we wrote our first contract on Remix, which gives us hello world. Cool. So to make things a little bit complex, let's try to do something else. Right now, remember we just returned this hello world string from here. Let us create a global variable in the contract itself and then access it from here. So instead of returning this hello world, we'll return that global variable. So let's do that. To create the global variable, we need to write the data type, which in this case is string. There can be other data types, but we'll know about them in future contracts. Then we name this variable. I'm naming this message, and then we write an is equal to button, and then in double inverted commas, because whenever we write strings, we need to write them in double inverted commas, and then we write hello world. Let me add Ethereum as well so that we don't confuse it. Ethereum, and then let me add exclamation. And just like at the end of each line, we need to add a semicolon over here as well. Cool. So now here, instead of returning hello world, I'll just return message. Cool. So if I click compile as expected, it should throw an error. And if we read this error, we know that we need to use view instead of pure. Why we need to use view instead of pure? Because as I told earlier, we use pure only if this function is accessing variables from within the function. It is not accessing anything from outside the function. But in this case, we are accessing this message variable, which is declared outside the function. But because we are just viewing the variable and not updating it, we can call this function view. And I'll again save it, compile, and then see the compiler ran successfully and we got this green tick. We'll go back. I'll delete this deployed contract so that it does not confuse me later. Also, I'll clean the console, and over here, just like previously, I'll again hit deploy. So yeah, we can see the hello world contract deployed over here. We can expand it, and then we'll see this get me string function because that is what we created. Then we can click on get me string, and we should ideally get this string, which is hello world Ethereum. And let's click on it. Ta-da, we got that. So that is about it for this video. Let me summarize what we learned in this video. So we started with smart contracts. Before smart contracts, we understood what are traditional contracts. Then we understood what are contracts. Then we got started with Solidity. We got to know about this amazing tool, which is Remix. Then we learned different sections of Remix. Later, we created a small smart contract, a hello world contract, which returns just a message. We tried to deploy it and then uh, ran transactions on it. So basically called functions on it. And then we updated the contract to create a variable in the contract itself, a global variable, and then access it and return it as an output. Cool. That's all for this video. Hope you liked it. Let's see you in the next video. Bye bye.